This video is brought to you by mywayteaching.com.
Next we can solve one problem. Okay, so here the question is, on a ship sailing in Pacific Ocean where temperature is 23.4 degrees Celsius, a balloon is filled with 2-liter air. What will be the volume of the balloon when the ship reaches Indian Ocean where the temperature is 26.1 degree Celsius? Okay, so again, once again you read the question, and I will solve this. I will solve this question. Okay, so here what they have given solution. I will write down the solution. This is the solution. Okay, so here v1 is equal to 2 liter given, and t2 is equal to 26.1 plus 273, means they have given 26.1 degree Celsius. In Celsius, if you want to convert into Kelvin, you are getting you have to add to 273 to 99.1 Kelvin. Okay, see here T1 is equal to 23.4 plus 273 Kelvin is equal to 296.4 Kelvin. From from Charles law, we know that Charles law V1 divided by T1 is equal to V2 divided by T2. Okay, so now you want what is V2? V2 is equal to V1 into T2 divided by T1. So if you are substituting 2 liter into 299.1 Kelvin divided by 296.4 Kelvin, so how much you are getting? 2.018 liter. So this is the answer. Okay, next concept is, in that the next is Gay-Lussac pressure temperature relationship. Okay, this is a pressure and temperature relationship. It states that at constant volume, pressure of a fixed amount of a gas varies directly with the temperature. Here pressure is directly proportional to the temperature. P by T is equal to constant, equals to K3. Okay, so this relationship can be derived from the Boyle's law and Charles law. Pressure versus temperature graph at constant which is I will show that figure. Okay, so this is the pressure versus temperature. This is gas. Each line of this graph is called isochore. Each line of this is called isochore. Okay, next is Avogadro law. In this volume amount relationship, okay, this is status that the equal volumes of all gases under the same conditions of temperature and pressure contain equal number of molecules. So V is directly proportional to N, where N is the number of the moles of the gas. V is equal to K4 into N. The number of molecules in 1 mole of gas, the number of molecules in 1 mole of a gas has been determined to be 6.022 into 10 raised to 23, and this is known as Avogadro constant. Okay, so this is about Avogadro constant. Next is since the volume of a gas is directly proportional to the number of moles, this is directly proportional to V is bright. One mole of each gas at standard temperature and pressure. So 1 mole of each gas at standard, this is the standard temperature and pressure, will have the same volume, will have the same volume, standard temperature and here, okay, will have the same volume. Here STP, standard temperature and pressure, means 273.15 Kelvin, that is at 0 degree Celsius. Okay, temperature, where this is temperature, and what about the pressure, means 1 bar. This is we calling standard temperature and pressure. These values approximate freezing temperature of water and atmospheric pressure at sea level. At STP, molar volume of ideal gas or a combination of ideal gases is 22.71098 liter per mole. Molar volume of some gases, I will explain you about the molar. This is the molar volume in liters per mole of some gases at 273.15 Kelvin and 1 bar. This is about the argon, carbon dioxide, dinitrogen, dioxygen, dihydrogen and ideal gas. Next, so before going to the ideal gas equations, I will explain you, that is number of moles of a gas can be calculated as follows. We can calculate the number of moles of a gas, number of moles of a gas, that can be calculated by N is equal to small m divided by m, where m is the mass of the gas under investigation and m is molar mass. This is the mass of gas and this is molar mass. Okay, so thus we can write, thus V is equal to K4 into small m divided by m. So that equation, this is 1, this can be written as m is equal to K4 into D, where D is the density. We know this density of gas is directly proportional to its molar mass. Now we can say that this is where this is called density. Okay, the density is directly proportional to molar gas. A gas that follows Boyle's law, Charles' law and Avogadro law strictly is called an ideal gas. Okay, so here what is meant by ideal gas first. So a gas that follows Boyle's law, Charles' law and Avogadro law strictly is called as ideal gas, is called an ideal gas. Next, coming to the what is meant by ideal gas equation. There are three laws which we have learned till now, that is Boyle's law, Charles law, and Avogadro law. So they are combined together in a single equation which is known as ideal gas equation. This is ideal gas. Okay, what do you mean by ideal gas? Then what do you mean by ideal gas equation? Write it down. The three laws can be combined together, can be combined together in a single equation which is known as ideal gas equation. Okay, here at constant temperature, first is at constant T and N, V is 1 by P, that is known as Boyle's law. Correct. This is first one. At constant P and N, V is directly proportional to T, that is Charles law. At constant P and T, V is directly proportional to N, that is Avogadro law. Thus we can write V is directly proportional NT and inversely proportional to P. Then we can write V is equal to R into NT divided by P, where R is proportionality constant on arranging the equation, where R is a constant. Okay, and PV is equal to RNT, R is equal to PV divided by NT. R is called a gas constant. This is called gas constant. So it is same for all the gases, therefore it is also called universal gas constant, or it is called a ideal gas equation. So note down. Okay, next. So we know that V is equal to nRT divided by P, where N, R, T and P are constant. This equation will be applicable to any gas under those conditions when behavior of the gas approaches ideal behavior. Volume of 1 mole of an ideal gas under STP. So consider under STP now. Okay, so here condition 270 ISTP means at standard temperature and standard pressure. Okay, so here standard temperature is 273.15 Kelvin and 1 bar pressure. So we are getting 22.71098 liter per mole. Okay, so value of R of 1 mole of an ideal gas can be calculated under these conditions. So value of R, now we can calculate value of R for 1 mole of an ideal gas, that can be calculated as R is equal to 10 raised to 5 PA Pascal into 22.71 into 10 raised to minus 3 meter cube divided by 1 mole into 273.15 Kelvin. So after calculating this, we are getting 8.314 joule per kilo per mole. So at STP condition used earlier, 0 degree Celsius, where this is ideal gas equation is a relation between 4 variables and it describes the state of any gas, therefore it is also called equation of state. Okay, next, in this only, let us now go back to the ideal gas equation. This is the relationship for the simultaneous variation of the variables. If temperature, volume and pressure of a fixed amount of gas vary from T1 V1 and P1 to T2 V2 and P2. Okay, if temperature, pressure and volume, that is from, they are varying from T1 V1 and P1 to T2 V2 and P2, we can write this as P1 V1 by T1 is equal to NR. Okay, and you know this equation and you write like P2 V2 by T2 is equal to NR. So equating these two equations, okay, this is equation 1 and this is equation 2. So P1 V1 by T1 is equal to P2 V2 by T2. So RHS side are both are same, that's why we are equating LHS side. And this equation is also known as combined gas law. This is also known as combined gas law. Okay.